Welcome back for section 6.5 for Math 120. So we're looking at applications of decimals and percents. Now the first part of this is really kind of going back to your roots of doing adding and subtracting and multiplying and dividing of decimals by hand. Now obviously we have calculators out in the world, so you can definitely do these a lot faster that way, but God forbid that there's an electromagnetic pulse that wipes out all electronics in the world. What are we going to do? Well, like I said, this is just going to be a quick refresher of how we can do stuff by hand. But the intention is with the order of operations and stuff, we're going to be able to use calculators to kind of simplify some of those steps. So you're not doing these long, drawn out calculations to solve one single problem. So, okay. Now, the big thing about adding and subtracting decimals is if we're doing it by hand, we want to line up the decimal points in a column and then perform the operation. So in this case here, we can line these up. And again, make sure those decimal points are lined up. If you want to keep track of some spots by putting in extra zeros, obviously that's fine. And then we can add as we normally would. And the decimal point stays in the same row or the same column. So in this case, we could add pretty quickly, and we get 11.315. So pretty quick. Now for something like this, where we got the second number is bigger than the first one, now technically we have to fall back on the rules for adding signed numbers in general. So if the signs are different, we subtract. If the signs are the same, we add. Now, in this case here, we first should change it to an addition problem before we apply those rules. So in this case, we can squeeze in a plus sign before the subtraction, and then we get our minus 12.955. So now we can see for sure that this is a case where the two signs are different. And so we're going to want to subtract these two numbers. Now, which number goes on top? Remember, the bigger number, regardless of the sign, has to be on top. So 12.955 will be on top. 9.74, I'll add a 0, will be on the bottom. And now we can subtract. So we can do these subtractions pretty quickly. If you remember the rules and the borrowing, I'm kind of doing it without showing all the little steps, but we had to borrow obviously to do this last subtraction to get to the 3. Now the most important thing though is what's the sign of our answer? Is it positive or negative? And hopefully you're saying negative, because that's the size of this one is much bigger than the positive side. So we get a negative 3.215. All right, so that's adding and subtracting. We can go into multiplication and division, and the rules are there. The big thing about multiplying by hand is we got to be careful about the decimal points again. So in this case, though, the total number of decimal points in the numbers being multiplied is the number of decimal points in your final answer. So looking at this first one, we got 1 decimal point on the first number. We got 2 decimal points on the second one for a total of 3. So our final answer should have 3 decimal points. So if we do this by hand, and we can multiply this fairly quickly. So 14 carry 1, 11 carry 1, 5. And then we got to shift over 1 spot, so we'll put that placeholder of a 0, so that way we don't put it right underneath. 3 times 7 is 21, carry 2. 3 times 5 is 15, carry, plus 2 is 17, carry a 1. 3 times 2 is 6, plus 1 is 7. So now we can add this up, and we get 8224. And now the decimal point, remember, you got to start all the way to the right and then work your way back to the left. So we want 3 spots, so it should go right there between the 8 and the 2. And so that is it, and we're done. So 8.224 should be your answer. Now division is a little bit trickier because, again, We want to divide by an integer. We don't like to divide by anything other than an integer. So basically the second number in our division problem has to be an integer, a whole number, or something. When we don't have that, like in this case here, we have to adjust both of the numbers. And we can do that by moving both decimal points the same number of places to the right, only as much as we need to. So in this case here, if we move the decimal point 2 places to the right, and this one 2 places to the right, that fixes our problem. So now our problem essentially changes to 101,982.5 divided by 2147. So now if we're dividing this by hand, well, this is going to be fun. So the second number is on the outside, first number is on the inside. Now, because our decimal point is right here, we just got to be careful with it, and it's going to move straight up from where it was. So there's our decimal point. So now we just got to be careful on how we're dividing. So we got a little over 2,000 here. Can't go into 1, can't go into 10, can't go into 101, can't go into 1,019. It can go into 10,000 and change. How many times? I'm thinking 5 is going to be a little too much, so let's start with a 4. So 4 times 7 is 28, carry a 2. 4 times 4 is 16, plus 2 is 18, carry a 1. 4 times 1 is 4, plus 1 is 5, and 4 times 2 is 8. So there's that multiplication. Now we got to subtract. Aren't you glad calculators are around? So let's do a little subtraction. We got to borrow, so 11 minus 6, 5 is 6. Drops that down to a 9, so we're going to bring down a 1. So now we can bring down the 2. And so how many times does 2,000 and change go into 16,000? Well, I'm guessing it's going to be a little under 8, so probably let's go with a 7. So 7 times 7 is 49. Carry a 4. 28 plus 4 is 32. Carry a 3. 7 plus 3 is 10. Carry a 1. 15. So there's that. Now we can subtract again. So we got to borrow. So 12 minus 9 is 3. Borrowed. So 9 minus 2 is 7. Borrowed. 0 minus 0 is 0. And bring down the 1. And then bring down the 5. Whew, almost there. I think 5 might go into 2,000 might go into 10,000 and change 5 times. So let's try a 5. Maybe we get lucky. So 35, carry a 3. 5 times 4 is 20, plus 3 is 23. Carry a 2. 5 times 1 is 5, plus 2 is 7. And then 5 times 2 is 10. Yay! It comes out evenly. Whew. Would have been bad if it didn't, right? Okay, now they don't always come out nice. Sometimes you got to keep adding zeros to keep, and it goes on forever and ever. But in some cases you get lucky. But remember, calculators are there. Now, if you get stuck, if you want to try it by hand, but you're not sure if you did it right, definitely use that calculator to check. So, all right, let's move on to rounding decimals. So when we're rounding decimals, now we talked a little bit about it before, but that was just dealing with whole numbers or integers or something like that. When you have decimals, the rules are basically the same, but that last step is a little different just because you're usually on the right side of the decimal point and not on the left side. So let's just read through them real quick. Locate the digit to round, the rounding digit. And then if the digit to the right of the rounding digit is greater than or equal to 5, we add 1. Less than 5, do not change the rounding digit. And then after you've made those changes, or not, you want to drop all the digits to the right of the rounding digit. And again, this is when on the right side of the decimal point. So looking at the first one, they want us to round this to the nearest tenth. So here's where you got to be careful. You got to know your place values on the decimal side. So the 10th, what spot on the right side is the 10th spot? You remember? That is the first spot. So that would be the 2. So the number to the right of the 2 is a 4. We don't care about the rest of it. All we care about is just the single number to the right of the rounding digit. So that 4 tells us we want to leave that 2 alone. So we're leaving it alone. So now step 3, drop all those digits. So this should be 46.2. Done. All right. What about to the nearest hundredth? So tenths was the first spot. Hundredths is the second spot. Yep, you got it. So that's the 4. Now the number is a 5. So that says we have to add 1 to the rounding digit. So this becomes 46.25, and that's it. There's nothing else after it. You drop all those digits after the rounding digit once you've changed it, or not. So, okay, let's keep going. 10,000th. Well, just might as well just go right from scratch. So you got tenths, hundredths, thousandths, 10,000. So 10,000ths is the 1. 10,000ths is the 1. So the number to the right is 0. Leave it alone, and then drop them off. So 2451. All right. Now the last one says to the nearest unit. Now what the heck is a unit? Well, unit is just basically the first place value on the left side of the decimal point. So the unit would be the 6. So number to the right of the 6 is a 2, so we leave the 6 alone. So this is just 46. Done. Now, if we had kept looking at other values on the left side, that's when we do need to keep those zeros in there to keep track of all those place values. So just be careful. On the right side, we don't need the zeros. On the left side, we do. Okay, so that wraps up rounding. And I think we're going to stop there, and then we'll pick up the percent stuff in the next video. So see you in a minute.